So now we've gotten to what I really wanted to cover for CST 630, and that is standard in, standard out, and standard error. So anytime you run a command, there's going to be one of two possible results. Either the command will complete successfully and give you some sort of output, or it will result in an error and it will output some sort of error message. So standard in is 0. Standard out is 1. And standard error is 3. And so we can take the output, we can also redirect the outputs of our files, or we can redirect the inputs of our files. So if we wanted to run some file or some process, some package on this computer, we would receive the standard output of some information. So if we use the ps command, we list the processes that are running. If we use the w command, we get a list of everyone who is logged into this computer. If we use the ls command, we can see what directories are in the current directory that we're in. So these are all standard output, and it's being displayed on the screen. But if, for instance, we didn't want to see the output of the ps command, maybe we want to save this for later, we can take the ps command and we can redirect the standard output to a file, process list.txt. And now when we run it, we do not see the results of the ps command. Instead, we can see it inside of the process list.txt. So this is especially helpful when you run an entire nmap scan, and instead of copying and pasting it out of the terminal into a text editor on the graphical user interface, you can redirect the results of your nmap scan directly into a file, and then use that file to sift through and record your results so that it's not so transient. We also have standard error. So if I do ls documents, I see a list of all of the directories that are inside the documents folder. If I did ls some made up directory, it would give us an error. Cannot access SA, no such directory found. So if we did ls some made up directory and redirect that into a directory list, we would receive on the screen an error because it is not standard output. This is a standard error. If we wanted to redirect the standard error, we would type to arrow error list. And now, since we've received an error, it has logged the error into error list. So if I head, I can now see what the error was. With redirection, it is important to understand that one arrow will overwrite anything after the arrow, but two arrows will append it to the bottom. So we have our directory list. So I want to head directory list, process list. So I want to see what is in process list. Head process list. So now I have a few entries in process list. If I want to PS 2 arrows into process list.txt, it will append our new process list into process list.txt. So when we read it again, now we've got it twice. So this is important to remember, that if you are trying to log different results over time and you want to continuously add new information to a file, you should use the 2 arrows instead of the 1 arrow. Otherwise, every time there's a new entry, it will overwrite all of the old entries. So now we get to one of the aspects of Linux that makes Linux so powerful, especially the Linux terminal. And that is the key that you've probably never touched on Windows, and that is the one just over the Enter key. And it's called the pipe. So if you type Shift and then press the key that is right over the Enter key, you get this long line. And in Linux, we call that a pipe. So a pipe is going to take the output of a command and input it into a new command. Alright? So this way we can search for, or we can use it to process the data that has come out of that command without having to read it or view it or copy it and paste it and do multi-step processes. So you can actually pipe command 1 into command 2, which is piped into command 3, which is redirected into some file.txt, and command 2 and 3 process whatever comes out of command 1, so that by the time it gets to some file.txt, it is completely exactly what you need and nothing extra and lacks nothing. So let's give you some examples of how this might work. So, dmessage. Alright, let's clear that. Let's find some command that has a lot of information spit out. We have, there is uptime, where's that cat? So we are going to read the proc mem info, and so this gives us a lot of information about our memory and what we've got in the memory. So we can use this to, if we spit out proc / mem info, which is just basically it's going to read this out and it's going to write it onto the screen, but we don't want to write it onto the screen. We want to search it. And to search through things in terminal, we use the grep command. So if I want to grep through this and I only want to find mem total, that will give me only the line that contains mem total on it. So if I have some long, lengthy piece of information and I want to search through it quickly, I can use the grep tool, the grep command. Also, if I want to see it, but I also want to redirect the output into a file, for instance, I want to see what the answer to my Nmap scan is right now, but I also want to copy it into a file, you can use, let's go, Nmap T4, let's go, just nmap 192.168.1./24.1/24, and we want to pipe that into T. And T is, just like it sounds, it is a splitting command. So it's going to split it between two different places. So we are going to split it into root documents and map scan.txt, and I'm going to leave the second one blank because I want it to display on the screen as well. And so now the nmap scan has started. It's going to run its scan, and the results will be recorded to nmap scan.txt. cd documents cat nmap scan.txt, and I didn't let it run very long, but there's the start of my nmap scan and what it managed to record into nmap scan.txt. So piping is very important because you can pipe things and modify information left and right with several different commands very quickly. So if I wanted to maybe I want to use this mem information again, so proc/mem-info. So I've got that, but I want to only get the first 10 lines, pipe that into head, and in the first 10 lines I only want to see lines that start with M. Then this is what I receive when I look for the first 10 lines with only things that have the letter that start with the letter M. So you see M locked is below the first 10 lines, so I don't receive that. But buffers, cache, swap cache, active, inactive are all filtered out because they don't start with the letter M. Letter capital M specifically. Another tool that you can use is awk, and awk is abbreviates, or not abbreviates things, but trunicates things, so shortens it down so that maybe you don't want to receive the sizes, maybe you just want to receive the first column. There's a lot of different packages on Linux that can modify your data so that it's easy to read and easy to use. So I'd recommend, as you get in here and I list all these commands out that maybe you're not familiar with, you can still use the man command, and you can look up something like awk, and awk will tell you that it's the conforms the definition of the language. Version is based. The command line lists the options of Gawk itself, and a very great synopsis. Integrated debugger. Very long option. So it in here somewhere it'll tell you basically what it does and how to use it and what the options are and the arguments here, and you can learn a little bit more about it and then practice using it. Or if you wanted to learn about the grep tool, which is the one that we use for searching, then you can man grep, and this is all the information about how to use grep. It searches for a pattern in each file. Okay. Or if you caught it at the very beginning, I used echo, so we use man echo. And echo is a command that basically repeats back whatever is listed after it. So it is handy to use for something like echo, this is some information, and then you redirect the standard output of echo into information.txt, and now instead of seeing this as some information, I get a new file called information.txt, and if I read it, then I get the same thing that I had just typed into echo. So that is how you redirect the output of one command into a file, or you can pipe the output of one command into the input of another command, and you can use this to create data and save data onto your computer while you're doing the labs in CST 630, or anytime you need to use Linux in the future. If you have any questions, please comment or give me an email, and thank you for listening.